So welcome to the last session. My name is Lorenzo Bettini. I'm a researcher at the University of Turin, doing research on programming languages and type systems. I'm also a consultant for Artemis. I'm a project lead of the Eclipse project EMF Parsley. We just demoed that after lunch. And I'm also a committer for SWT-bot. And today I'm going to show some techniques to test the implementation of an Xtext language without using additional frameworks, just what Xtext provides. But first of all, are you all familiar with Xtext? Okay. So for those who are not familiar, do you have an idea what Xtext is? Okay. So anyway, it's a framework for implementing languages in Eclipse together with all the Eclipse IDE tooling. So first, what not to do? Don't try to modify the language, then start another Eclipse instance and check manually that everything works. That's really bad, and that won't work in the long run. Of course, if you're here, you know that you have to write tests. So I prepared a small example that you can find on GitHub. That's an adaptation of the example I shown at the Eclipse conference this year. So this is a small example, okay? It's an expression language. You can declare variables with constants, arithmetic expressions, comparison, Boolean expressions, standalone expressions. You have string concatenation. From this input, I want to generate a Java file that basically interprets those expressions. Okay, this language is simple, but it's still a nice example to show how to test everything in this Xtext language implementation. So you know that you start from a grammar in Xtext. So defining the grammar for only the constant parts of the expression is easy. But you soon get into trouble when you start to define the grammar rules for expressions because they are recursive and they are left recursive. And Xtext grammar can't handle left recursion. Of course, there's a well-known technique, it's called left factoring, to avoid to have left recursive rules. So it's rather easy to use this technique, but that's a good point to start testing, right from the start of the development, the parser, to check that when we applied left factoring, we get the associativity and priority in the expressions correctly. So Xtext already generates a project for testing. And in this project, you find these injector providers, because Xtext uses dependency injection in all the places, okay? In particular, Google GUI's dependency injection. So with these providers, it's rather easy to perform tests on your language. And you have an injector provider for headless tests that don't need the UI, and an injector provider if you really need the Workbench to test. And first of all, try to avoid the UI when it's not required. Most parts in an Xtext implementation can be tested without UI, with plain JUnit tests. And we will see in the end that, well, of course, you know that plain JUnit tests are much faster than tests that require the UI. So this is a typical test case. I'm going to use extend. Again, who's familiar with extend? So it's a kind of better Java with less syntactic noise. You have type inference, you have lambda expressions, extension methods. Even if you're not familiar with extend, you should be able to see the code of the examples. And most of all the tests will be much more compact and much more readable. First of all, in this talk, I'm not going to show any production code. I'm going to show the code of the tests. Of course, everything is online on the GitHub repository. Don't worry if you don't get all the details. I just want to show that you can test easily and in a compact way, in a pretty readable way all the aspects. So first of all, you have to use this JUnit Xtext runner. Use the inject with annotation using one of those injector provider that Xtext generated for you. Then you can inject some utility classes that are found in the Xtext testing framework. So testing the parser, what does testing the parser mean? It means that you can test the program correctly, if the program is correct, without any syntax errors, but most of all you want to make sure that the abstract syntax tree, the runtime representation of the parser program, it is as expected. So with the right associativity of expressions, multiplication comes before additions, for instance, with the operator precedence. And to do that, you just inject this parse helper that Xtext provides for you. And this parse helper parses a string, which is the input program, and returns the AST. So actually, the parser is only the initial stage of implementing a language. Most of the time, you have in the implementation, you will have to manipulate the abstract syntax tree. You have to visit that, probably modify that, and then from that abstract syntax tree generate code. So you really better make sure that the AST is constructed as you expect. So testing the parser is really important. What can we do? Given an AST, we can give a string representation that somehow highlights the precedence and the associativity. And then we check that this representation is as expected. We can do that with a method which translates each AST element with parentheses, which highlight the associativity. And then what we can do, we can simply say, okay, given this input, I expect that the abstract syntax tree is constructed this way. So I'm sure that the multiplication has the precedence over the addition. And you do that also for comparison expressions, for Booleans. This way, you are sure that you applied left factoring correctly and that the AST, it is as expected. Okay? Now you can start doing all the other stuff. That's just the beginning, of course, because now it comes with the validation stage. So validation means checking that the program is semantically correct with some sort of semantics that you define. For instance, in this language, I want to avoid forward references. So I decide that it makes no sense that I refer J before it is defined. I have to implement this check. And usually you do that in the validator, but let's do that progressively. What I need to do is to inspect the AST. So let's write a separate class which has nothing to do with validation. I call that expressions model utils, that given an element returns the list of variables declared before that element. Okay? I'm not going to show the implementation. It might be tricky to get it right, but and we can test this class separately before implementing the validator. So for instance, given this program, I can check that here there should be no variables declared before. Here, no variable. Here, I expect that I is returned. Here, I expect that I and j is returned. Okay? So now this model util class works as expected. And why not start code covering right now? So you can use Jacoco and Eclipse. Are you already familiar with these tools? Yeah, of course. And although we used Xtend generates readable Java code. So in the end, Jacoco will cover the generated Java code. I know it might be harder to deal with generated Java code, but in the end, it's not that hard. I mean, here you are sure that all the parts of the generated Java code is code covered. Okay, so you can still use Jacoco even if you use extend. Now that we are sure that our model utility class works as expected, I can implement the validator. If you're familiar with Xtext, you know that you have to write some methods annotated with the @check annotation. Now it's really easy to implement it. You just check that given a variable reference, if that variable reference is not contained in the variable defined before, you issue an error. And you issue an error, and you want to place the error marker right on the variable reference. That's what you want to do. Now let's test that. There's a utility class called validation test helper. Although I'm talking about error markers, I can still test the validator headlessly. I don't need the UI, because this validation test helper provides some helper methods to do that, to test that headlessly. So what I do, I have to, same part here we saw at the beginning. I still need the parser helper, and now I use the validation test helper. Given this input, I expect an error, because this J is a forward reference. And I can assert that the error is placed on a variable reference, and that the type of the error is forward reference. And I can also assert that the error marker will be generated exactly in this text region. Okay? So now I'm sure that error markers will be generated correctly, even if I'm not using the UI. Feel free to interrupt me for any questions. But again, don't worry if you don't get all the details. Just to give an idea that you can test these things in a really compact way. Yeah?
I have a question. So with this test, you're actually testing two things, the validator and the utility class, right? Because you're not injecting mock validation.
Well, actually, the utility class has already been tested, and it is injected in the validator. Now,
also the validator test will fail if this utility class do something.
Yeah. Of course, in the suite of the tests, if the utility class is wrong, you get all tests have failed. That's why you should test that before going here. Here, I'm mainly interested that the error marker is put right at that position. And of course, you should also test that given a correct input, you get no error. Okay? Now, I will skip this part, although I work on type systems, but so usually you should check that your program is correct with respect to types, so that you only assign the right type expressions. You have to implement a type system, test it separately, and then you implement type checking in the validator and test that. You see the code in the example, okay? But I will skip that. And let's go to the most interesting part, code generation. Now, what I want to do is, for every input file, I want to generate a Java class with the same name of the input file in the package expressions with an eval method. And for each variable declaration, I want to generate a Java variable declaration. And for each standalone expression, I want to generate a system.out.println. So of course, I implement the generator. And now I'm using this compilation test helper. There's a few additional setup to do, but again, don't worry about that. Once you know that, it's really easy to do. And note that I will use also jdt.core, and we will see why. So first of all, by using this compilation test helper, I can specify an input, and then I can assert that it compiles to this output. Okay? So I'm checking that given this input, I generate this Java code. Usually this kind of test is considered fragile, because as soon as you change something in your code generator, these tests will start to fail. So someone discourages you from using this test. It's kind of subjective. I really prefer to have full control on my code generator. So I prefer that tests fail and I update them all, but I really concerned to have full control on the generated code. But another thing that you can do is that you can test that the generated Java code is actually correct Java code. So I'm calling compile class, and what this does is calling JDT compiler and compile your generated Java code. Okay? So with this test, I assert that what is generated from this input file is actually correct Java code. If the Java code I generate contains error, this test will fail. And another interesting thing is that you can also test an instance of the generated Java code. So in this case, I generate the Java code, compile it, and then at runtime instantiate the generated Java code and check that the generated Java code gives me the expected output. Okay? Don't worry about the details, but that's really important, because you have full control on what you generate. You know that what you generate is correct, and you know that the generated code behaves at runtime as you expect. Okay? Of course, you will have to write many of these tests for several situations. Now, we basically tested the runtime. Now let's start testing the UI. So I want to test the content assist. I want to test the integration with the Workbench. I want to test the outline. So testing the content assist. I want to make sure that the code completion that Xtext generates is correct. Okay, because Xtext also provides all these, also generates all these nice IDE tooling like content assist. I have to use this base class, and be careful, now I have to use the UI injector provider, because now I have to really run these tests as JUnit plugin tests. Now I really need the UI. I can't do without. And be careful, if you're not using Java 8, put some memory. And so this base class provides a nice Java API. I can say, given this input, at this point, I expect that I is proposed by the content assist. Okay, so since I already defined I expect that I is proposed. And I can also assert all the proposals in a given part of the program. Okay, just with this readable API provided by this abstract class. Why it is important? Why is it important to test the content assist? Because usually you will have to tweak the content assist. For instance, with this for this language, we want to avoid to propose forward references in a given part of the program. Because, for instance, here, I must not propose J because it wouldn't be correct. I should not propose S because it's string. It would be incorrect here. So I can tweak the content assist. I'm not showing the code. And then I can test that the content assist works as expected. And I can say, in this part of the program, that's the cursor, I don't want that I is proposed. And now I can check that my customized content assist works correctly. And I can do the same with other API. Not going into details, but you can check all these situations. Another important mechanism to test is the Workbench integration. Okay? Now we want to check that my DSL integrates correctly with the Workbench. I have already tested all the runtime parts. Now I want to make sure that if I put an input file in an Eclipse project, this leads to the generation of a Java file in the source gen folder. And that everything compiles fine after the generated Java code is generated. To do that, I'm using another base class from the Xtext testing framework, Abstract Workbench Test. Xtext provides these two nice utility classes, Java Project Setup Util and iResources Setup Util. And then I can also use the standard API from core resources to programmatically accessing the Workbench. It might not be easy at the beginning, but once you get acquainted with the, once you get knowledge about these APIs, it's really easy to write these kinds of tests. So what I do in this setup is I create a Java project. I'm using the APIs from these utility classes. I create a Java project. I add the Xtext nature. If you're familiar with Xtext, you know that you need the Xtext nature in your project. Then I write a method that creates a file in the project with some given contents. Now, this is cool. You can trigger the Eclipse building mechanism. So I'm triggering the auto building. I wait for the auto building to finish. I retrieve all the error markers from the problem view, and I assert the expected errors. So given a valid input file, I expect no error after the code generation and the auto building. If I put an invalid input file, because this is an unresolved variable reference, I expect one error. You can also assert the contents of the errors, okay? But you know, we have already tested that in the validator test. So now we are testing that our DSL integrates correctly with the Eclipse Workbench. By the way, you have to trust me, but during this, the development of this example, I never ever launched Eclipse and manually checked anything. Okay, I'm really just wrote these tests. You have to believe me, but I promised I done right that. The outline. So this is the default outline. Xtext generates also an outline for your language. The default outline for this DSL is not very beautiful because it shows elements that make no sense. So I can customize the outline to have this outline without children, showing just the string representation of the variables. And I want to test that without running the Workbench manually. Unfortunately, there is not a base class, so I implemented one. You can find that in the code of the example. And with this base class, you can test the outline as simple as that. Given this input file, I assert that the outline is like that. It's a string representation that also highlights the structure of the outline tree. Just as simple like that. I'm basically done. I tested the runtime and the UI. So some statistics, of course, with plain JUnit test, everything is fast. So running the complete test suite for the runtime part, 72 tests, only requires 2 seconds and something. We have 8 tests for the UI part, and this requires much more because you have to run the Workbench during the test. So try to avoid that when you can, of course. So you can integrate all the tests in the build. If you use Maven Tycho, you have to configure the Tycho Surefire plugin. Of course, for the headless tests, you have to set the UI hardness to false. And if your DSL needs access to the Java class path, you might run into troubles running these tests. In that case, what I usually do, I switch to the Maven Surefire plugin. But that's usually required only if your DSL really needs access to the Java class path. For the UI tests, you have to specify to use the UI hardness and to use the UI thread. If you're using SWTBot, you have to set the second one to false. So if you want to add other functional aspects to your DSL, you should be able to test them as well. If there are no base classes, what I would suggest to do is to have a look at the Xtext sources. Xtext is, they have a huge test suite. I think tens of thousands of tests. So they test basically everything. And you can have some inspiration. That's what I've done for the outline test. I saw something in the code base and I adapted. Other testing frameworks, you should really consider having a look at Expect, because it's a nice framework for testing Xtext languages. I don't have time to get into the details, but the idea is that you write expectations right in the input file. And then from that you can run JUnit tests. That's even more readable. Of course, for functional testing, you can use, you can use the Xtext testing framework, as we saw, for easy things, let's say. But if you really want to test the interaction of the user with your DSL UI, you can use SWTBot, RCP testing tool. Last but not least, Joomla. And of course, try to use continuous integration service. Jenkins is my favorite. It also gives you some nice reports about tests and code coverage. And it integrates with Jacoco. So I know this is a simple DSL, but we managed to test everything. We managed to get 100% of code coverage. I know that it's not a complete guarantee that everything is going to work, but it's a good starting. Okay. Or you might want to use Travis. It's rather easy to set up. I'm using both Jenkins and Travis for this example. Okay, so now we are at the conclusion slide. It's small advertising. So this is my book on Xtext, and there's an entire chapter about testing. Okay, so I took the inspiration from that chapter. I'm really concerned about testing. And in Xtext you can really test. You should really test everything. And there are some special discount codes, IDS 50 and IDS 20. They should be available for a few days to get some discounts. And that's basically all. Please evaluate the session, and if you have questions. Yeah?
As you mentioned, expect for the grammar validation and also content assist and how I think and expect to be probably the nicer way for testing this, or what do you think?
Sorry?
That for these parts which you can run in JUnit, like the parser and the validators, and also for the content assist in the UI and for hovers, then expect is quite nice because you have your expectation in the text. I mean, for outline and so on, I think the UI approach is nice because this is really something that you probably would not write in such a file.
Well, I think it should be only a matter to add that feature to expect. Or,
yeah. But creating a Java project and let's generate something, this is really not fitting into expect. So
no. They have something for that.
Oh, really?
They have a test for the Workbench that is kind of similar. You specify that you create a Java project with an input file, so that they can also test that Workbench integration functionality. I haven't been using expect for a long time, but I saw that they also can test the Workbench.
I just think that this is nice in a moment when you do this you have an expected result and you have something that you are having as a sample and then you want to just literally compare it, and then for this expect is perfect. And if you have something where you do more logic in your test, where you just don't simply compare, then the way how you explained might be the better one.
Yeah, I think it might depend from the context. You can use them both. You can have different test suites implemented with different frameworks. Yeah. Other questions? Okay. So, time for beer.